Hey everyone, welcome to this video. We are going to talk about how AI models work. And to start off, in this diagram, we have inputs that are passed to a model with weights, and then that model with its weights gives outputs. So what happens here? We multiply the inputs and the weights together and add them up to get the outputs. So we could do input 1 times weight 1 plus input 2 times weight 2 plus input 3 times weight 3 equals the outputs. And models, or AI models, that translate languages, generate images, or have a conversation with you, etc., are able to do this by having ideal weights. So as you can see, these weights are really important. So that begs the question, what are weights? What are these things that are really important? Well, weights are just numbers. Let's say we have a really simple model for calculating your taxi fare, where x equals the number of miles traveled. So that model for calculating your taxi fare could be 10x plus 3. And in this really simple model, it has two weights, or two numbers, which are 10 and 3. Weights are also called parameters, but for the rest of this video and the rest of this course, I'm just going to call it weights because I think it's more intuitive to understand if I call it weights. And again, models that translate languages, generate images, have a conversation with you, are able to do this by having billions or trillions of ideal weights or numbers. Whereas our taxi model had just two weights, if we can have billions or trillions of these weights, we can do some really amazing things. And OpenAI's, who developed ChatGPT, GPT-3 has 175 billion parameters. But how do we set these billions or trillions of ideal weights to be the correct numbers so that these ideal weights can do all of the amazing things that AI is known for? Well, first off, the weights are set to random numbers initially, so the model will be terrible initially. For example, a model for correctly labeling pictures of dogs or cats won't be able to tell the difference, or a model for chatting with humans would send gibberish back because it has really bad initial weights. They're just random numbers in the beginning. Then, during training, use loss to tell the model how correct its output is. For example, tell the model it had incorrectly labeled a picture of a dog as a cat, and that instead of outputting all of that gibberish that I'm not going to bother pronouncing, it should have instead output, "Hello, how can I help you?" Then, do math stuff with calculus and the loss to update the weights to be better and closer to their ideal numbers. I think it's easier to just visualize this. So during training, we pass inputs to the model, which has its weights. And now remember that the weights are just numbers. And you can think of these weights almost like the brain cells of the model. But it's just numbers at the end of the day, right? Then the model will generate outputs. Like it will say, I think this is a picture of a dog or a picture of a cat. Or it could try to send a response back to you, like it's chatting with you as a human, right? Then we use this error slash loss to tell the model how good or bad its outputs are. And again, that loss is used with calculus and some math stuff to update the weights of the model to hopefully have better weights, so it has better outputs to give a lower error slash loss. It's used to update the weights again. And if we do this update weights enough during training and perfectly or in a very good way, hopefully by the end of training, we have really good weights, so we have really good outputs. And so we want weights that minimize the error slash loss. And this right here is the most important diagram in this course. And if you understand this diagram, you now know how deep learning works, or put more simply, you now know how AI is trained. It really is this simple. Now, the model for calculating your taxi fare, where x equals number of miles traveled, when working with a model with just two weights like 10 and 3, it is easy to see what each of those weights do. So for the number or weight of 10, we know that this 10 weight, it means for each mile you travel, you get charged 10 extra dollars. It's also easy to see what this weight of 3 does. You could think of the number 3 as like a fixed cost or like a startup cost when you get in the taxi, right? That even if you get in a taxi and don't travel that far, you will always be charged $3. But once you work with models with billions or trillions of weights, it is no longer possible to exactly see what each of those weights do. Okay, that's it for this video. Thanks for watching. See you all in the next one.